Hi students, welcome to VTeach. In this video, we are going to discuss about Jacobi and Gauss-Seidal methods for solving system of equations numerically. First, let us see each iteration model individually. First, let us see Jacobian iterative method. In this method, it is the classic and simplest form of method, but it is somewhat slow. The answer obtained will take some time. It is somewhat slowest method. Working rule. First of all, take the given equations. The given equations will be converted in such a form such that the first equation will be written as x is equals to. Second equation will be written as y is equal to. Third equation will be written as z is equal to. Next, do the iterations with the initial values x0, y0, z0 is equal to 0. You will substitute those values in the taken equations x equal to y equal to z. Next, you will obtain some x1, y1, z1 values. In the second iteration, in place of x, y, z, take those initial values as x1, y1, z1. You will be obtaining x2, y2, z2. Take those as the initial values of iteration next iteration. That is for x3, y3, z3. You will be taking the initial values of x2, y2, z2 and so on. So in this way, the process will be continued until the values of the consecutive iterations will be equal. If the iteration number 3 value and the iteration number 4th values are equal, then stop the iterations and those are our desired values. This is very easy problem. Now see here, solve the following equations by using Jacobian iteration method. Here they given the question 20x plus y minus 2z is equal to 17, 3x plus 20y minus z is equal to minus 18, 2x minus 3y plus 20z is equals to 25. So what did I say? Write the first equation as x is equal to. That means simply keep here x term and bring all other terms to the other side. Next, only x should be there on the left hand side. Bring this 20 also to the other side. You will be getting 17 minus y plus 2z. So this is our equation number 1. Similarly, convert the second equation also as it is. Only keep y term this side and bring all other terms to the other side. Y is equals to. Similarly, z equation also will be treated as in the same manner. So for iteration 1, in the equation 1, what is equation 1? This is our equation 1. Put x, y, z values as x0, y0, z0. That is 0. Initial values will be only 0. So after substituting 0 values, I am getting x1 as 0.85. For y1 also, put x0 and z0 as zeros. So I will be getting here y1 value. Similarly, for z1 also, in place of x and y, put x0, y0, that is zeros. I will be getting z1 value. So while you are going to next iteration, in place of x and y, now substitute this x1, y1 and z1 values as initial values. So here x2, in place of y you will be having y1, in place of z you will be having z1. So we will get x2 value. Similarly for y2 also, in place of x substitute x1, z, z1. You will be getting y2 values. Similarly for z2 also, in place of x substitute x1, in place of y substitute y1. We will be getting z2 value also. Now these x2, y2 and z2 values will be taken as initial values for next iteration. So to obtain x3, substitute in place of y and z, y2 and z2. For obtaining y3, in place of x and z, substitute x2 and z2. Similarly for obtaining z3, in place of x and y, substitute x2 and y2. You will be getting x3, y3 and z3. Next iteration 4. For iteration 4, same procedure. For in place of x, y, z, substitute the previous iteration values x3, y3 and z3. So x4, y3 and z3. For y4, x3 and z3 you will use. For z4, in place of x and y, x3 and z3. Sorry, x3 and y3. Now for iteration 5, use the previous x4, y4 and z4 values. Simply substitute in the 1, 2, 3 equations. Similarly, I have done here 7 iterations. In 6th and 7th iteration, all the values of corresponding x values, corresponding y values and corresponding z values are equal. So stop the iterations there. Now our required or desired x values will be x equal to 1, y equal to minus 1 and z is equals to 1. This is our final answer. So until the iterations are equal, you should not stop doing the iterations until the value should be equal. Now see the next problem. Given 3 equations, you have to check whether the conditions are satisfied or not. That is, for first equation, x coefficient should be greater than modulus of sum of other two coefficients. That is, modulus of 27 should be greater than 6 modulus of 6 plus modulus of 1. It is obviously equal. Similarly, coefficient of y should be greater than modulus of x coefficient and z coefficient. Similarly, modulus of z coefficient should be greater than modulus of y coefficient plus modulus of x coefficient. Okay. Now write this in the form of x is equal to y is equal to, that is 27x is equal to 85 minus 6y plus z. In the next term, bring this 27 to other side. We will get 1 by 27 into 85 minus 6y plus z. So now similarly write down z is equals to from the third equation. So 54z is equals to 110 minus x minus y. Take that 54 to other side, you will get this equation. Now for the first iteration, substitute x0, y0, z0 is equals to 0 in the first equation. So for x1, substitute x0, y0, z0 equals to 0 from this x equal to equation. Similarly for y1, substitute x0 and z0 in place of x comma z. For z1, substitute x0, y0 in place of x comma y. You will getting x1, y1, z1. For second iteration, take these as initial values and do the calculation. For x2, in place of x, substitute x1, this is y0, y1 and this is z1. Consider the basic initial equations. From that, in place of x and y and z, if you are calculating x2, in place of y and z, put x, y1 and z1. If you are calculating y2, in place of x, substitute x1 and in place of z, substitute z1. If you are calculating z2, in place of x, substitute x1, in place of y, substitute y1 values. You will be getting x2, y2, z2 values. Similarly for third, fourth, fifth iterations also. For third iteration, substitute for x3, y2 and z2 values. For y3, x3 and z3 values. Sorry, for y3, x2 and z2 values. For z3, x2 and y2 values. Similarly for fourth iteration and fifth iteration, substitute those values and take these values as initial values for iteration 4 and take x4, y4, z4 as initial values for iteration 5. Similarly for iteration 6 also, take initial values of x5, y5, z5 for calculating x6, y6 and z6, and similarly for iteration 7 also. Here we can notice that the corresponding values of x, y and z are equal. So stop the iteration there, and these are our final values, x value, y value and z value. So you should do the iterations until the consecutive iteration values are equal. So this is our Jordan iteration method. Now I hope you all understood it, students, because it is very easy. Just take the previous values and substitute here and obtain the values and do the iterations until the values of any two iterations are, the values of consecutive iterations should be equal, not any two. The immediate iteration value and the above iteration value only should be equal. Okay, I hope you all understood it, students. Thank you.